All right, welcome to section 3.2. In 3.2, we're going to be looking at measurements of variation. So in the previous section, 3.1, we looked at measurements of center and discussed the mean, median, mode, and mid-range. These are measurements of the fluctuation in data, or how it varies, and so they're called measurements of variance. There's three main types that we find. There's the range, the standard deviation, and the variance. So let's just start with the range, and what I'll present to you is a data set, and we'll find each one of these off of that data set. So for the range, we will be needing just to do something simple. We need to just take the high of the data and subtract away the low. The range is just the spread of the data from high to low. How far does it cast its net? And so what I have down here is a data set that appeared in the book. And it has 8 data points: 212, 77, 121, 104, 153, 264, 195, and 244. And these represent costs of hotel rooms in the city of Las Vegas. And so one measurement of variation is called the range. And so the range is simply, like I mentioned before, high minus low. Looks like the high is 264 and the low is 77. You would just simply grab a calculator like I'm doing right now, type in 264 minus 77, and you get a nice answer of 187. So if these were hotel room prices like they claim they are, there's a difference of $187 from the highest priced one that they found to the lowest priced one that they found. So that's as simple as the range is. The standard deviation is the average distance the data points are from the mean. And so I'd like for you to know that definition. That definition sparks applications that it has, but it's just the average distance the data points are away from the mean. There's two formulas presented in the book. One is one in which you can see the actual mean being subtracted, and it looks like we're finding the average distance data points are away from the mean. The other one they refer to as the shortcut formula. It's a little bit easier to program in a calculator, and it's the one that's used most often when we ask you to find standard deviation. So that's the one I'm going to present and allow you to practice. I believe it's also the one that they use most often in the examples in the book. So standard deviation, let's talk about its symbol. The symbol for standard deviation is S, and I got to be very specific. S is the sample standard deviation. So that's what we have here. There's more than 8 hotels in Las Vegas, and that's everything in chapter 3. Everything's a sample. And so they're going to use S. The population one that's perfect is represented by the lowercase sigma. So represented right here. This is the population standard deviation. You'll see this symbol as we move forward in the book, particularly in chapters 7 and beyond. They'll have the population standard deviation in a lot of the formulas and a lot of the consequences as well. Remember, the population standard deviation is perfect. It's a parameter. The sample standard deviation is not perfect, but it can be a very, very good predictor of what the population is. So if I'm not going to show you or utilize just plugging in the data and hitting magic buttons to get the mean and the standard deviation. However, if you did do that, note that there'll there'll always be an S and a sigma given, and they're different from one another. So you'll have to know whether you're dealing with the sample or the entire population. What I would like to do instead of that is to utilize the formula for standard deviation. So let's find the standard deviation. The standard deviations formula is going to look a little bit daunting, but again, they call it the shortcut formula because it's relatively quick to do. Here's the formula. N times the sum of the x squares minus the sum of the x's, that whole thing squared, all divided by n times n minus 1. And everything's under that square root. And so we'll go through this formula, but you can see that it's asking for some specific things. And we got to make sure that we understand order of operations, right? And so let me come in and highlight something. I'm going to highlight it with a red highlighter. This is the sum of the x squares. And then I'm going to come in here and do a blue highlight. That's just the sum of the x's. And then consequently squaring it. So the red one is asking us to square the x's first and then add them. And the second one's asking us to add up all the x's the way that they are and square that result. The results will not be the same. You probably know that from your algebra days, but you can't distribute a square over the sum. The other variable that's in here is n, so I'll highlight that in green. N is the sample size, right? And so what do we know? We know that for our problem, n is 8. Right? There's 8 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8. That's what n always refers to, is the sample size. So if I come in and start filling in my formula, look how much I can do. I know that this is 8. And I know that this is 8, and 8 minus 1 is 7. So just from counting up the data, I get a lot. The question is what are these other numbers? And then how do I put that all into my calculator? Well, we know what they are. Let's work on the blue one first. That one has numbers that are there. So if you look at the blue one, which is the sum of the x's, which will be our second parenthesis, all we have to do is add up the x's, which is 212 plus 77 plus 121 plus 104 plus 153 plus 264 plus 195 plus 244. And we come up with, and I'll put it in blue for emphasis, 1370. Awesome. That easy, just adding up those x's, just doing exactly what the formula is telling us to do. Nothing hard. So how do we get the other one? Well, the other one wants us to take 212 and square it, and add to that 77 squared, and 121 squared, and 104 squared. Whoops. I might have just lost my Apple Pencil battery. So let me just talk you through it while I quickly charge that up. You're going to just square each one of those as you go down. So it's 212 squared, and I would recommend not writing out what that is, plus 77 squared, plus 121 squared, plus 104 squared, plus 153 squared, plus 264 squared, plus 195 squared, plus 244 squared. And we're going to get a number that's fairly large. This is the number that I'm seeing, 266966. Oh, apologize, a little bit different. I didn't see that for what it was. Too many 9s and 6s. 266996. And so that's what we have. We have, sorry, I'm going to try to plug this pencil back in again. We have that calculation to do. And so you have to plug that into your calculator. My advice is do the square root the very last thing that you do. So what we should do is type it in your calculator like this. I'll put it in black. 8 times 266996 minus 1370 and raise it to the second power. Your calculator will know to raise the 1370 to the second power first, then do the multiplication, then do the subtraction. But we needed to do all of that before we divide, so we're going to hit an equals. And so let's do that together. So if you plug that in right now like I'm going to do, 8 times 266,996 minus 1370 squared equals, you should be looking at the number 259068. 259068 is what's coming out. Then we're going to hit immediately divide, and what you should see is the calculator putting up some kind of answer, or maybe even showing you that previous one. And then this is needed, parentheses 8 times 7. So you're going to hit divide by, then open parentheses, 8 times 7, and close those parentheses. And you're going to get a number, and you're going to hit equals, and you're going to get a number 4626.214286. And there's a reason why I'm writing that number down. So remember, what we have now is this number. Well, where is that? We just figured out this, 4626.21428. Now you don't have to write it down to just retype it. At this point, remember, this is what's sitting in my calculator. So I'm going to hit the square root button. So hit that square root button. Mine's right above the square. And it looks like this. And then I can bring up my previous answer by hitting the second function and the ANS key. And it will bring up that 4626 number, and I don't have to retype it. And then I hit equals. And that's going to take the square root, and it's going to tell me 68.016 ... So the book is rounding these to 1 decimal point beyond the original set of data. So as I look at this one, yeah, they're following that rule here as well. They are rounding this to 68.0. So the test should tell you how to round it, but they're rounding it out to the tenths. But that is matching the answer in the back of the book for this problem, 68.0. And you're done. That's the standard deviation. So on average, the hotel prices are differing from the mean by an average of $68. So that's how you find a standard deviation. A little bit lengthy, but still doable. I tried to choose one with numbers in the hundreds so you could see how big it gets. I don't think they do much other than that. Variance, the best way to describe variance is through its symbol. Its symbol is s squared. The variance is just the square of the standard deviation. It's very rare that it's called upon in future chapters. They only call upon the standard deviation. And that's because they're really interrelated. So the variance is s squared. So what's the variance in our problem? So if I go to do the variance, and that should be your most common experiences, given a set of data, find the range, standard deviation, and variance. The variance is actually on the screen. Let me go ahead and highlight it. The variance, I'll highlight it in yellow, is right here. The variance is the result right before you take the square root, because the variance is s squared, so you would square the 68 and you come up with this number. But it's better to just write it down, because remember, we rounded that 68, so if we square it, we won't have the exact variance. But if we were lucky enough to have gone through the calculation, we can just name it as 4626, and remember, they're going to go out to the tenths, or the 1 decimal point beyond the original set of data. That's the main part of section 8.2. I'll create another video that's, I'm sorry, I said 8.2, section 3.2. I'll create another video that's related to, that's still in the same section, 3.2, but is doing standard deviation of a frequency table, just to keep these videos relatively short.